Let's now take a look to an exam question that relates, particularly this second sub question, to what we've been talking about this lesson. The first part is a common part. I know this for a long time. Anyway, the question is, the complex numbers w and z are defined by w equals 5 plus 3i and z equals 4 plus i. Express iw over z in the form x plus iy, showing how you're working and giving the exact values of x and y. Okay, this should be simple. I'm not going to go into details on how to do this. I'm assuming that you already know how to do this very quickly. Just multiply I by w, eventually we'll end up with this. Then divide by 4 plus I, you already know what to do. Multiply the top, multiply the bottom. Eventually you have this, which you simplify into that. Let's now go to the second question, which is the one that matters to the topic in question. Find WZ, and hence, by considering arguments, show that tangent -1 of 3/5 plus tangent -1 of 1/4 equals pi over 4. Let's just calculate WZ first. Okay, so it is just this. And now you have to reach that, considering arguments. What do they mean with this? They mean that you have to use this over here that we just saw in lesson. So the argument of w plus the argument of z equals the argument of zw. So let's calculate the argument of zw or wz first. So that's just tan -1 of 17 over 17, which is 1. So that's pi over 4. So here you have that. Let's now see the argument of w. Where is w? It's there. So it's tan -1 of 3 over 5. So there you have that. And the argument of z is tan -1 of 1 over 4. So using this equality over here, you can then just substitute. Argument of w is tan -1 of 3/5. Argument of z is tan -1 of 1/4 equals argument of zw, which is pi over 4. And you have proven this.